Feeling like taking a coffee break? So do I. What about we talk about Java 14 records? Java 14 records are a preview feature in Java 14. It's extremely exciting, and one day or another it will make it to the JDK. So, first of all, what is a record? What is it meant for? First, a record is some kind of a bean. You remember this old Java bean stuff? Back in the very early days of Java, it was created just to carry some data and was there mainly to back up graphical component classes. Now, it's not the case anymore. A Java bean is still a data carrier, but maybe Java AWT is not used anymore, and Java Swing is probably kind of obsolete. But we still have JavaFX, that works very well. The main concept of a Java bean is the concept of property. What makes a property in a bean? A common idea is that a property is a field backed with a getter and a setter, and it's not really accurate. In fact, a property is defined by the presence of a getter. Take a user class, for instance. It has a getName method. Then this user class has a name property made by this getName method. If the user class also has a setName method, then this property can be both read and modified, right, through the setName method. So we said that this property is mutable. But there are examples in the JDK with classes with immutable properties that are not backed by a field, right? Having a getName and setName method does not necessarily imply that I have a name field in the user class. Most of the time it is the case, but it is not mandatory. Take the string class, for instance. It has an isEmpty method, so it defines an empty property, which is a boolean, thus the getter may be named isEmpty instead of getEmpty. There is no setEmpty method, so this empty property is read-only, it cannot be modified, and it is certainly not backed by an empty field that would be boolean in the string class. If you check the source code of the string class, there is no such field in a string class. This notion of property goes to the bean concept, to the record concept. So the concept of components is roughly equivalent to the concept of properties in the Java bean landscape. Now, there are several differences. First, a component is immutable. You cannot mutate the value of a component of a record once you have created that record. And second, you don't have getters in a record. A getter does not exist. This is a bean concept. You can create a getter if you wish in a component, and that is going to work. But the name of the getter in a record does not start with get, it's just the name of the component. So take a record named point, it has a single component named x, for instance, then you have an x method that is going to return the value of that component for that object. A record is implemented with a regular class. So creating a record is just like creating a class. Instead of using the class keyword when declaring a record, you are going to use the record keyword. So public record point is going to create a record that is named point. Every class that is declared as a record, in fact, implicitly extends a special class from the JDK, which is the record class. So when creating a record, you are not allowed to extend anything, because the compiler will make you extend this record class, that in turn extends the object class. So a record instance is also an instance of an object that does not change the type system we have in Java. A record cannot extend any class, but it can implement any kind of interface. So if you wish to add some behavior to a record, you can have it implementing any interface, and you can put default methods in this interface. This is a good way of sharing some behavior among a bunch of different records. Let us see what it gives on the code. So to create a record, you basically just create a class, and instead of using the class keyword, you just use the record keyword. It's the only difference. And you need to declare the components of that record when you create that file. So public record point, and then the two components, which are here x and y, two integers. This class record should be saved in a point.java file, just like a class. regular class, and that's basically it. Just by writing that, you have a record. So how are we going to compile that? Well, first of all, we need to check the version of Java we are running. You need to have a Java 14, that's for sure. Then if we try to compile javac, we get an error message, but that error message tells us that we should declare this javac that is using a preview feature. And to do that, we need to add this flag, enable preview. And it's not quite all, because if we run that, the compiler tells us that we also need to check the dash source flag. So let us do that. Dash source 14 point.java. And now we have a properly compiled point record. So let us check what we have in this point record. We can see that we have, in fact, first a constructor that is going to take the two components as parameters, and then a toString equals and hashcode methods from the object class, and two kind of getters who do not have exactly the right syntax to be called getters. They are merely accessors to the component values. Note that we do not have any setters just because the components of a record are immutable. Let us create a main class that is going to make use of those records. So classical main method, that has not changed. We are just going to create a point instance, just like for a regular class, by calling the constructor. And we can just print out the result to make use of this toString method, p1 equals plus p1. Let us run this code. So compile the main class and the point class, great. And now run the main class. And here we have another error message that is telling us that indeed we are trying to use a preview feature from Java 14, but we need to make sure that the JVM is aware of that. So we also need to add the preview feature stuff when we're launching our code. So Java enable preview and the main class. And now we can see that this toString method is working properly and generating this message for our instance of the point record. Let's go one step further, create a second point with different component values, let's say 20 and 20, fine, and a third one with other component values, and we're going to choose in fact the same values as P1, 10 and 10, just to see if we compare them using the equals method, we indeed have a true result. So we are going to check if P1 is equal to P2, just by calling the equals method that has been generated by the compiler for us, and do the same for P1 and P3. And what we expect, of course, is that P1 is equal to P3 using the equals method. So let us compile that, run the code, and indeed we can see that P1 is different from P2. The values on which P1 and P2 have been built are different, but the values of the components of P1 and P3 are the same. So even if the instances are different, they will be equals if they are compared using this equal method. So let us go back and let us print out the hash codes of P1, P2, and P3. So here is the hash code of P1, p1.hashcode. Same for P2, and same for P3. Here is P2, here is P3. Let us compile this code and run it. Okay, and then run. And we can see that indeed the values of the hash codes of P1 and P3 are the same because they are equals when compared with this equals method. And the hash code of P2 is different from the two others, which is of course what we expected. So now we are going to add some content in this record class, because in fact we can add any kind of method in it, just like in any regular class. Let us compute the norm of a point. It's just the square root of the square of y plus the square of x, right? And we can also say that the point class implements, for instance, comparable of point. So we are going to be able to put them in a sorted set, for instance. Let's just import this Java util stuff, and then implement the compare to method that is defined in this comparable interface. And we're going to compare them with the norm, for instance, which is just a simple example. So double.compare this.norm and other.norm. Fine. Now let us make use of this compare to method. Let us import also the Java util package because we're going to need it. And then create a list of points. Let us make use of this very nice factory method that we have in Java 9. And we're going to put P2, P3, and P1 because it's not the right order when we're going to put them in a tree set. So now we can just print the content of that list and create a sorted set on the content of that list. Let us make it a tree set and build it on this points list. Fine. Now let us print the content of this sorted set. This is sorted and sorted. Great. So let us compile this code, fine, and check the result. So here we can see that on this list we have our 3 points that have been added, and that have been added in the right order. This is the exact semantic of the list. And on this sorted set, the doubles have been removed, so we only have P3 that has been left, and they have been properly sorted according to their norm. So here on the sorted set example, we can see that both elements have been properly used. First, the equal hashcode methods from the points record, and then the fact that the record is indeed comparable. Let us try one last point of the record, one last feature of the record. It's the possibility to add some validation, for instance, in a constructor. So here I've just created a constructor in the record sense. That is, when you add a constructor to a record, you do not need to add the components of the record because the compiler can do that for you. You can add them, but it's not mandatory, right? So here I just let them apart, and I'm just going to write some validation code in this constructor, telling that if x is a negative number or if y is a negative number, then the point should not be constructed, telling that no negative value should be registered for x or y. So now we can make use of this validation rule. Let us go back to this main class, just create a corrupted point on the value -10 and -10. Fine. I do not need to go any further because running this code should be throwing this illegal state exception, which is the case. So it's very easy to add some validation to a constructor, just like that, and leverage the fact that a canonical constructor is always created by the compiler by copying the values of the components to the internal state of the record. So let us see now how this record feature compares to what Lombok is able to do. If you're a Lombok user, you may think to yourself, oh, but all this I can already do it with Lombok, so there's no need for me to use records. In fact, the implementation of records and what Lombok does is a little different, and this is what I would like to show you now. So I've just created a Lombok point class, which is basically the same as the record we just created. So we just need to edit this class a little to make it a proper Lombok class. So this is a class. Of course, we need to get rid of this component declaration. It should implement comparable of Lombok point, and so this compare to method should take a Lombok point. Of course, this constructor is not going to compile, so let us get rid of it. And let us create two private fields, x and y, of type int. And those two annotations, data and all else constructor, are what Lombok needs to generate all the code we are going to need. So I also just created a main Lombok class, which is basically the same as the main class we use to test the record point, right? The only difference, of course, is that this main Lombok class refers to the Lombok point and not to the record we just created. So let us compile it. Compilation is the same. The only difference is that we need to add the lombok.jar library to the class path. So let us compile that and run the code. And the same goes for the running of this code. We also need to add this lombok.jar library file to the class path. So let us run that. And we can see that basically the code generated, the result generated, is roughly the same. We can just point out that the value of the hash codes here generated by Lombok are not the same as the value generated by the record, So the algorithms behind that has to be different. So at this point, you may think to yourself that the technology brought by Lombok is roughly the same as the one that the records will bring in the future. So why moving from one to another if I'm already using Lombok? What I would like to show you is that, in fact, under the hood, things are quite different. If you check what Lombok has generated, you can see that you have everything. Getters, setters, because the property were mutable, equals hashcode to string, and of course this compared to. And if I check the implementation generated by Lombok, here is the implementation of the hashcode method, for instance, you can see that the algorithm of this hashcode is just added inside the bytecode of the class. So the way the hashcode is computed is added itself by Lombok. And here is the algorithm used by Lombok. Now, if we do the same for point, we can see what has been generated in the point class. We can see that this class is final. It also has a pseudo getter equals hashcode and toString. But if you check the bytecode generated, for instance, for the hashcode method, we can see that it is very different than the one from Lombok. In fact, the algorithm to compute the hashcode is not put in the bytecode of the point class, or the point record. Here we have a call to invoke dynamic, meaning that the way this hashcode method will be executed will be decided at runtime by the JVM. So it means that if there are major improvements in the computation of the hashcode, whether in the algorithm or in the performances in the future, having this kind of compilation will leverage this improvement of performances in the future without having to recompile the code. Why? Because the algorithm is not in the code, and that's it. So this is a point that is really interesting with the record that Lombok doesn't have. And with records, there is more to come. In the future, record will support a very important feature of the upcoming version of Java, which is called pattern matching. We will be able to deconstruct record. This is not the case so far, and with this deconstruction, many more things are going to come. What can we get from records? First, it's a regular class. It can implement an interface. It's serializable. We didn't talk about that, but yes, it is serializable. It's built on the notion of components. The equals, toString, and hashcode methods are automatically generated at compile time, leaving the implementation for the JVM to choose it. You can still add some behavior if you want to do some kind of validation to prevent corrupted records from being built. And you can override the classical methods from object, toString, equals, and hashcode if you need that in your applications. Remember that record is a preview feature. It is not here to stay. It will appear in an upcoming of the JDK, but it may change, the behavior may change, so everything that is true in Java 14 might change in a future version of Java. But don't worry, I'll bring this information to you. So that's it for today and the Java 14 records. Thanks for watching. Talk to you soon.